All right, algebra benchmark 9.1, inequalities. We need to graph the solution sets to these two inequalities. If I'm looking at A, one involves absolute value, the other one's a parabola. The one that involves the absolute value is the straight one, this one right here. Looks like an upside down V. And the one that involves the parabola is the parabola, the curve. And if I want to pick, there's a bunch of areas here. There's 5 sections. There's one here, one down here, one in the middle, one on top, and one over on the right side that we have to try points in. Now, the longest way to do this problem is to actually pick a point in each section, an x and a y, and plug it in for x and y in each equation in both inequalities. And if you get a yes and a yes, then you'd shade that section. If you get a yes and a no, or a no and a yes, or a no and a no, then you wouldn't shade it. I'm not going to do it that way. I'm going to do it the shorter way, which is basically just looking at each inequality separately and shading above it or below it or inside of it or outside of it. So if I look at the absolute value function, I'll take a point that's obviously outside of it, that's not on a line. 0, 0 is the easiest one to look at. Now I'm going to try to ignore the red parabola right now. I'm just going to look at the green function here, the absolute value that's upside down. Now this dot is outside of that or above this function. So if it works, if I plug it in and it works, I'm going to shade above that line. If it doesn't work, I'm going to shade below that parabola line, or that absolute value line. So I'll plug in 0, 0. So I get 0 is greater than or equal to the opposite of the absolute value of 0 minus 4 and plus 2, and then just solve it. This is negative 4. So negative out front. The absolute value of negative 4 is 4. There's still a negative out front. And then the last step is 0 is greater than, maybe I'll write it up here. 0 is greater than or equal to negative 2. Now is that true? Is 0 bigger than a negative number? That's a yes. So what I'll do is this point right here, the origin, is a yes. If that point works, then all the points that are on the same side of this line, or this absolute value function line, all those points will work. So I can essentially shade everything, ignoring the red parabola again. Everything up there will work. If I try the point 1, 2, 3, 4, 4. So 4 over and 1, 2, 3, 4. This point here, if I plug that in, it'll work. If I plug that in, it'll work. All these points here will be solutions to that first inequality. I'm not sure about the parabola yet. So now I switch to the parabola. I'm going to take the same point, that 0, 0. Now it's going to get messy here. So what I'm going to do is I'm going to erase this part for now. I'll even erase that work. You can rewind it if you need to. And just look at the parabola. Take a point that's obviously not on the parabola line. Again, I can use 0, 0. And all I'm going to look at is the parabola itself. If my point works, then all the points inside the parabola work. If it doesn't work, all the points outside the parabola will work. So plug in 0 here. Plug in 0 for y and 0 for x, and solve it. So 0 is less than or equal to 1/2 0 minus 2 squared minus 6. 0 minus 2 squared is positive 4, because it's negative 2 times negative 2. Copy the rest. So 0 is less than or equal to, half of 4 is 2. 2 minus 4 is negative 2. So is 0 less than or equal to negative 2? Is 0 less than a negative number? No. So this is a no for the parabola, which means the yes side is outside the parabola, out here. Okay, and I want to shade the yes side. So let me just get rid of this mess. So I'm going to shade this stuff. Only looking at the parabola, not worrying about the other equation, the other inequality. Now going back to what I had before, I had that green shading above the absolute value before, so I'll put that back in. And then my answer, my final answer, is the overlap of the two. So I carefully kind of shade real dark where the green and the red overlap. And over here, it's going to be like this line here, over in this corner. And that goes on forever. You can't see it, but it goes on forever in that, in those directions. It'll go up that way. So there's the first one. Second one, x is greater than or equal to negative 4. That's a line. I'm thinking vux. So it's a vertical line at negative 4. I go to x is negative 4. And because it's a vertical line, it's got an undefined slope. X equals a number. Vertical line at negative 4, just draw it. Now I glanced quickly to see if it was or equal to. It's underlined right here, so I make a solid line. If it was not underlined, it would have been a dashed line. And then x is bigger than that, so all the values with x bigger or to the right will be shaded. So that goes on forever that way. My other equation, y is greater than or equal to negative 2/5, is it? I can't even read it. 2/5 x plus 3. I'll write that bigger. So I'm going to plot my 3. I'm going to just work over the top of the stuff here. So 1, 2, 3. And just do my rise over my run. So down 2 over 5. And just to make it more accurate, I'll go up 2 and left 5. And then again, I check. It's underlined, so it's a solid line. It's or equal to that line. So I can just draw my solid line there, put arrows on it. And the way I do it, the shortcut is, I think shade above the line. That's just the way I do it. To be safe, you try to point like 0, 0 and see if it's a yes or a no. So like try 0, 0. Is 0 greater than or equal to negative 2/5 times 0 plus 3? Is 0 bigger than 0 plus 3? Is 0 bigger than 3? Absolutely not. And again, I would say shade above the line because this is a no. So I'm going to shade the yes side, which is above the line. Now it gets pretty messy. My final answer, you have to kind of cut it off in the corner here. It's where they overlap. So it's all this stuff out here because it's an and problem. And then the last problem, it's just an inequality to solve and put it on a number line. So I'm just going to bring my x's to one side. Maybe I'll bring my x's to the left side. So I'll go minus 5x, minus 5x. So I get negative 8x. And then a plus 9. So I'm just going to minus 9 here in the same step to save a step. And just to reach here, negative 8x is greater than negative 16. Divide by negative 8 on both sides. Hopefully you remember the rule of whenever you divide by that negative number or multiply, you need to flip the sign around. Negative divided by negative is positive 2. So now I have x is less than 2. So I just, neither dot here, I guess it doesn't really matter. I'll just put a 2. Maybe I'll make this a 0 or something. Less than 2 means put a circle on it, shade to the left. And technically you probably should put a little x there because all those values that you just shaded are all x's. So every number is less than 2. Put an open circle on the 2 as a boundary point. Double check my work, subtract 9, negative 16, subtract 5, negative 8, divide, flip the sign around so it points left. Looks good.